This is the write-up video for the October XSS challenge. I am making this intro after I've recorded and edited the whole video, because to be honest, I was not even sure that this was going to work out. This challenge is so incredibly difficult and has so many things packed into it, so you are bound to learn a lot. At the time of writing, or at the time of saying this, only one person has actually solved this challenge, which is just insane. So if you want to learn a lot, then keep on watching. And if you want to compete in the next months, then be sure to follow us on Twitter and subscribe here on YouTube. But for now, let's get into the challenge, and let's start off today by reading some of the rules, because they are quite interesting for this challenge. First of all, the goal is to find an XSS, and that should happen on the latest version of Firefox, only Firefox. Our solution should alert the contents of a note of the victim, and we'll get into what a note is in a bit. We are allowed to use previous XSS challenges in order to solve this one, and the victim will open our link on a fresh private window after creating an account and a note, and the victim will have pop-ups enabled. And that's all you need to know in terms of the rules. So let's have a quick look at this challenge. So we have a notes application, we have a registration screen, we have a screen where we can create a note, and then we can also view our notes. And that's pretty much all you need to know. So let's get into this insane challenge and, well, of course, the solution to this insane challenge. Have fun, guys. Let's look around to see if we find something interesting. So whilst looking around, we notice a couple of things. First of all, this application is obviously written in Node.js and it uses EJS. There's also some sanitization going on using DOM Purify. And one more thing, after successfully registering, we see that we can create notes with HTML content. However, if we look at the code, we see that this HTML content is being sanitized using DOM Purify and using the latest version. So we need a DOM Purify 0 day in order to solve the challenge using that, and that is not the way here. If we navigate to /challenge/begin, we can see all of our posts, and if we click on a post or a note, we see that the URL format changes to /challenge/view and then a post ID. So these posts have some ID. One thing that we also notice is that when we try to add a post, there is no CSRF protection. So this means that we could potentially exploit a CSRF vulnerability to create a note for the victim, which is very, very interesting. But one issue is that the cookies here are set to same site strict. What does that mean? Well, that means that the cookie will not be sent by the browser in cross-site requests. Like, for example, if we were to have a payload hosted on an external domain and the victim clicks on that payload in this external domain. However, there is a very subtle difference between cross-site and cross-origin. And if you're not familiar with same site, or you don't know the difference between same origin and same site, then I would highly recommend reading this blog post by JobOps. But okay, what does that mean for us, that subtle difference? Well, we are allowed to use previous XSS challenges. And that means we can bypass same site strict, because challenge-0221.integrity.io, for example, and challenge-1022.integrity.io, they are same site. The site is integrity.io. But these two domains are cross-origin, since, well, they're different domains, and the origin is your full first part of the URL, so to speak. And since both are same site, if we make a request from one to the other, then this cookie will be present in the HTTP request. And that is very, very powerful for us. But there's one more issue. If we want to add a post, then we need a secret. And this secret kind of acts like a CSRF token here. But it acts like one and isn't one. And that's because, well, maybe it's possible to bypass this. So let's look at how the front end actually gets this secret. And it is done through a JavaScript file named getSecret.js. And this is a dynamic JavaScript file that generates, or that shares, the secret. And if we look at the code, we can see why it's dynamic. It generates the contents of this file, this JavaScript file, on the fly with the correct secret coming from the database. But this endpoint is behind some middleware. It's behind some middleware called isAuthid. And well, let's have a look at isAuthid. This is going to verify if the user is authenticated. So what does this middleware do? Well, it checks the request headers. It deletes a header if it starts with X dash or if it includes either IP or 4. And there's one exception there, which is the X real IP header. This one remains and it's not deleted because this whole challenge is running behind Nginx, and Nginx forwards the real IP of the user via this header, so we can't overwrite the X real IP header. But okay, after deleting all of those headers, it is going to try to verify a JWT token, and if this token is valid, it sets the user IP to our IP. And if the token is not valid, we will be redirected to /challenge/begin with the message something went wrong. So to recap, this get secret endpoint is an authenticated endpoint and it requires a JWT token. So if we can somehow get a valid token, then that means that we can perform a CSRF, and that would be a great first step into getting an XSS, but right now we don't have that, so we need to continue looking and look a little further to find something else. Let's quickly divert our attention to this themes page. There's something about it in the source code, and this is the code that runs when somebody tries to access /challenge/theme, but we haven't seen this page. And why? Well, that is because this first line here. Well, first of all, the endpoint is behind the same isAuthid middleware, so we have to be authenticated. But then it's going to check that we are coming from localhost, that our IP is 127.0.0.1. And if we're not localhost, then we'll just be redirected to the beginning again with an error message saying that the themes page is under construction. But it looks like the theme page is done because there is more here. We just need to be able to have an IP that is the local host. And luckily, if we look very closely at this check, it is not going to check the IP of the current request. It is going to check the IP that is stored for this user in the database. So that means that, well, maybe if we manage to make an account with a spoofed IP, that is localhost, then we are able to access this page. So we have to look at how these accounts are created and how this IP address is gotten in some way. And it seems that this application is using supercharge request IP, that library, to get the IP address. And we can take a look at their README page because it says that it will check HTTP request headers for the IP address. So first of all, it will check X forwarded 4, X forwarded, forwarded 4, X client IP, and then X real IP. Now we already know that X real IP is being used here because that's the only header that wasn't removed in the isAuthid endpoint. So X real IP is the one that's being used. Now, what if we send one of these other headers in our request? What if we add a X forwarded 4 header? Will that maybe bypass this check because that will be checked before the X real IP header? And that is a really, really smart idea. Sadly, as we saw earlier, all headers containing 4 and IP will get removed, so that leaves nothing there. However, let's have a close look at the registration route, at the function that does the registration. And here we see that it's not using this isAuthid endpoint. It's not using that middleware. So it's doing something a little custom here. And if you look very closely, you can maybe spot a difference between the way that this checks the headers and that the isAuthid middleware checks the headers. For example, this checks that our header cannot include X dash, cannot include IP, and cannot include -4, whereas the other one only checks that it can't include 4. So this is a little less restrictive. And that means that one of these headers that is being checked before the X real IP header, it kind of slips through the net, and that is the forwarded header. That would pass all of this, and maybe using that, we could spoof our IP and make an account with localhost as the IP. So if we check that and we register, then that works. And now if you try to access /challenge/theme using this spoofed account, we see that that also works, and we have access to the theme page now. And that is amazing. But if we try to go back to the main challenge, then we see that we run into an issue because we cannot use this cookie, this account, to create notes or anything, because every authenticated endpoint will check that our IP in the request body is the same as the IP in the database, and we have no way of doing that. So we currently kind of have this account that can only access the themes page and not the rest of all the things that are running on this challenge. And we also have an account that can access all the rest and that can not access the themes page. That is something interesting here. But okay, what is this themes page even doing? Because we have access to it, but what is happening here? Well, this application is going to look for 3 get parameters. The parameters callback, background theme, and color theme. And these are tied to a regex. So these are not just arbitrary inputs. There is something going on here. For example, the callback parameter should only contain letters, numbers, underscores, and dots. And the background theme and color theme parameters are even more restrictive because they need to start with a hashtag followed by 6 letters or numbers. So, okay, this is very limiting in what we're allowed to do, but let's take a look at how these parameters are even used. And we can do that in the theme.ejs page. And here we see that we have something called opener.theme. Opener dot or callback called with the background and the font. Okay, very interesting. We're calling a function we're calling something that we can supply. We're calling some user input here that it's always a bad ID. Very interesting, but since this callback is very limited, it may not have that big of an issue. But what does this opener stuff here mean? Well, if we look at how you might access this themes page, we find the function update theme, which is going to do a window.open of /challenge/theme. So by clicking this little button here on the page, we access the theme through a new window. Now our opener is the window that opens this themes page. So the main challenge page is the opener, and that is where we are executing something. So we can kind of have limited access to the parent page through this opener.callback function that is being called. And that is very interesting. We can call functions with limited arguments from the child to the opener, but we still have this whole issue where that doesn't matter because we cannot access the main page because our accounts can only access the themes and not the main page. And this is becoming a very big mess. So let's check out what else we can do in the next section. Let's dig into cookie tossing. So we can solve the issue that we have right now using cookie tossing. Because we have other domains where we have an XSS. For example, challenge 0222.integrity.io. Using this XSS, we can set cookies. And we can set cookies with a certain domain. And we can change this domain of the cookie to integrity.io, which means that this cookie will be present on all the subdomains on integrity.io, so also this challenge. Furthermore, we can also give that cookie a path. And by doing that, we can, for example, create a cookie, JWT, that works on every subdomain of integrity.io, so this challenge. The JWT token will be a token that authenticates for an account with a spoofed IP, and the path will be /challenge/theme. So this cookie will only be used on the /challenge/theme page. So what does that mean for a victim? Well, a victim for whom we set this cookie will just be able to use their normal account on every page, but if he visits the /challenge/theme page, that is when this specific cookie that we set is being used. And that is very powerful because this way we can use all the functionalities here on this challenge without having to do some insane stuff, because we have the 2 cookies that can make that work. So that's a really cool way of solving that issue. But obviously that doesn't get us really far. We still have a lot more to do. Now let's talk about something that I, to be honest, had never heard of before, and that is the SOM attack. And SOM attack, what attack? Well, SOM stands for Same Origin Method Execution. And we can actually use that in /challenge/theme. Now, if you haven't read more about this attack, definitely go and look it up. It's very advanced and really difficult to understand, but I'll do my best at kind of explaining it. So let's take this example where we have a page that opens a window, and then we change the location to a website that allows us to control the opener in the response and an endpoint that we want to access. Now, that window that we opened is going to have a script that is going to change location to that same website that allows us to control the opener in a response, and then an endpoint with a callback, in our case, the theme, and then use that callback to execute something on the opener, which is, in that case, the page that we want to access. That was a terrible explanation, I know, but let's see why this works. So, because we open a window, and then we change location of that first window, and then we expect to still be able to kind of execute things on that first window, which has changed. And that is possible because we use location.replace. Because if you just change the window.location, it adds an item to your history, then you can go back to that page and all that stuff. But if you use that replace, that doesn't happen, and that link between opener and child still exists. And that is kind of why we can do that. So maybe it makes more sense if I show this in kind of how this would work in the challenge. So in the challenge, if we have a limited POC and we want to look at the first post of the victim, what will we do? Well, we will first of all enable the themes page for the victim by doing that cookie tossing. Then we will have an iframe. And this iframe is going to run a script, which is going to do a window open to another frame that we control. Afterwards, it's going to set the location.replace for the challenge/begin, that page that shows all the notes that the user has created. So at this point, this iframe is just going to show the page that holds all the notes of the victim. But at that point, frame 2 has opened. And in frame 2, we have a script that runs after about 2 seconds. And that is going to do another location.replace, this time to challenge/theme. And this is going to have a callback. And this callback is going to be incredibly long because it's going to do something. So this is going to be a document.body.last element child, .first child, .next element sibling, and so on. Pretty much just traversing the DOM here, because at the end we're going to do a .click. And we want to click on the first note in this case. So that's what we're going to do in our callback, execute that click. And this is all allowed because we're just using letters and dots, which were allowed in this callback regex. We also supply a background theme, but that is just because our click is then going to be executed with, well, the argument of our background theme, but that doesn't matter. It's just going to execute a click and click on that first note. And that is how this attack works. And that is how we can, well, get access to that first note of the victim without knowing the GUID, because we don't know the ID of this note. So, okay, that's another very difficult attack, and at the end we will show how this all chains together, but we need to get all these things in place. But what is next now? Can we just create a node with an XSS and then use that XSS to get access to the first node? No, that's not possible, because we need to know the correct secret. And, well, how can we leak the secret? Let's find out right now. So let's leak the secret here so that afterwards we can perform CSRF and be all done, right? Okay, so first of all, let's take a look at how the secret is created. This is a crypto.random bytes, and then it's stored in a database. So there's really no way that we could ever try to guess this. That is not really feasible. And let's then take a look at how the secret is shared, and that only happens if our document.domain is challenge 1022.integrity.io, and the location.href is the specific create page. And only then will it send the secret across. So that is a big issue that seems unexploitable. We pretty much need to have an XSS on that specific domain in order to exploit this. That won't happen. But web workers can come to the rescue here. And if you've not heard of web workers, they are an object created using a constructor, worker, and they run a named JavaScript file. And that file contains a code that will run in the worker thread. And these workers run in an entirely different global context that is different from the current window. So accessing window won't work. It will return an error because it doesn't exist. So that is very interesting. There is no window or document object present in web workers, but our code here is still going to check if document.domain is challenge 1022.integrity.io or if our window.location.href is that. So what if we just create a worker that creates documents for window and window.location and document? Will that work? Well, here's the code and we see, well, we create objects for window. We create a function save secret, and this is just going to send the secret back to us, to our top window, if we want to exploit this. And then we set our window.location.href to that create page that it wants. We set document.domain to this challenge 1022.integrity.io. But note that window doesn't mean the window object here. This is just a object. The worker has no idea of window. But still, that works, because if we create a new worker a new worker on our exploiting domain with the URL of our attacker that links to this worker.js page, then that should, it does not work because, it cannot do that cross origin. It's not allowed to register a worker script that lives on another origin. So we can't register a worker that lives on a cross origin domain. Okay. What if we try to do this? So create this worker on our attacker domain and then share the secret? Well, that won't work because from our attacker domain, we still have that cookie that is same site strict, so that alt cookie won't be sent while importing the scripts from cross origin. But how can we bypass all of this? Well, to overcome this, we would need to have a file that is stored on the same domain where we have XSS. That's all challenge 0222.integrity.io. And then we can store our worker script there, and then that will work, then that will be able to execute. But we don't have any options to store this file. We don't have a file write anywhere. So that is kind of a bummer. Well, luckily, blob URLs come to the rescue here, and we have talked about them in the previous challenge, and they come back here. But what is a blob URL? Well, it's a protocol to allow file objects to be used as a URL source for things like images, download links, and binary data, and so forth. So this creates a URL with files that is very, very interesting, because what if I use this example POC? We have first of all, we're going to do a fetch. That's going to fetch our worker.js script. We're then going to get the text of that, and then we're going to create a blob URL. And this blob URL is going to look something like blob://https:// whatever, and then a URL. But it is going to contain our JavaScript file as data. So right now we have our worker script stored somewhere through this blob on the correct domain. And now if we register that worker, we notice that works, and we actually get the secret. And this is how we are able to steal the secret in this challenge. Wow. This video is getting crazy, but now that we know how to leak the secret, we can try to perform an CSRF and add another node to this user. Then we can use that SOM attack to go to that node and execute the XSS. But sadly, we haven't yet found an XSS on nodes, because the node title and node body are sanitized using DOM purify, so we don't really have an XSS. Okay, that's something we should probably fix. Well, let's start by looking in app.js, in the client-side app.js, and at the end we have this really weird thing going on here where an object.whoami is created with object.create null, and null, that means it doesn't have a prototype. Then if our domain is localhost, it's creating an admin that has markdown set to true, else we are just a normal user. And then we're doing an object.define property, and we're setting it to we're setting object.whoami to configurable false and writable false. And what that means is that at this point we cannot override these properties anymore. They are frozen, so we cannot change the account at that point anymore. Okay, so we have that going on. That all seems a bit fishy there. But let's take a look at view.ejs. And at the bottom here, we have this code that is going to check if we are an admin. And if we are an admin, it's going to run this try markdown, which is going to, again, parse our input. This is interesting because our input is first sanitized by DOM purify and then possibly parsed again. And that can cause some issues because DOM purify will only allow a tag if DOM purify knows about it. So unknown tags are removed. But we are able to smuggle XSS payloads inside known attributes. For example, this here, we have an H1 with an ID, and this ID contains our smuggled payload. And now, well, if DOM purify checks this, it's going to say, okay, that's all okay. And it is all okay, because if you just put that in HTML, that's fine. But if you parse that again, then that's not okay anymore. So in this thought experiment here, if we set document.body.innerHTML equal to marked.parse of our string that is allowed by DOM purify, then we see that that triggers the CSP. So we have a potential XSS here. This is something that works. So great. So we know now if we are able to enable that markdown on our account, then we bypass, then we have a way to get a potential XSS if we follow up with the CSP bypass and so on. So let's try to actually do that. And for that, we need to bypass this long check here that first of all is going to start with document.querySelectorAll or user type 0, and the attribute type has to be equal to admin. Okay, so how do we make that work? Well, we can try to use DOM clobbering here. Because every user has a body tag that has the ID user type, and that sets the type to normal user, but maybe we can clobber the DOM and add some stuff on there to make sure that that is not the case anymore. But for that, we need some kind of HTML injection somewhere, and it won't work because everything is, well, everything goes through DOM purify, so that's a bust. But every authenticated page contains the username of the user in the title tag without escaping the HTML. So this means that there is an HTML injection possible. This is heavily filtered, so you won't be able to get an XSS through here, but we can have a username, like close the title tag, have an HTML tag with an ID user type that has the type admin. And this way, that first part of the check, the document.querySelectorAll, is bypassed and we can become the admin there. So that's good, but we still have that whole second part that has the object.whoami.type needs to be admin, object.whoami.markdown needs to be true, and object.type needs to be admin. And you guessed it, from looking at this, it's very clear that we need prototype pollution. And if we look into the challenge, we see that this is using arc.js version 1.4, which is vulnerable to prototype pollution, and who other than Blackfan, whom we've talked about a lot in past challenges that required prototype pollution, has written a really nice little payload for this as a proof of concept that we can use. And if we try to use that proof of concept like such, we can see that we have prototype pollution, and then we can try to use that to prototype pollute object.whoami.type. Oh yes. We cannot do that because we configured it as read-only. It's frozen. We cannot change that due to this object.define property. Oh boy, we are in for one hell of a ride. But luckily, a few months back, Garrett Hayes from Portswigger wrote a really good blog on prototype pollution gadgets, and one of the lines from that blog is ES5 functions such as object.define property are vulnerable. If a developer does not specify a value property, then prototype pollution sources can be used to override properties. So if we pollute object.prototype.value, we can then override object.whoami.type, which shouldn't be possible. So here we show that it is possible. We obviously need to do that for, obviously also need to set our markdown to be true and our object type to be admin. But if we do all of that, then we can bypass that check and we can enable the markdown on our account. That way we have a possibility to get to a CSP. So I guess the next step, and hopefully the last step, is to bypass the CSP. Let's see if that's true. Okay, we still need the CSP bypass and then we have everything. So let's get into it. And we see that this CSP is a nonce-based CSP, and the nonce is dependent on our IP address. This means that every user with the same IP address has the same nonce. So that is something very interesting. But what are we going to do here? Well, in order to get the nonce, we are going to exploit something that is called a dangling markup injection. This is something that does not work in Chrome anymore. They fixed it there, but in Firefox, this issue is still present. So let's say we have a username, which is a closing title tag, and then an image that has a source with a quote, and then or attacker domain with a get parameter leak equals, and then we'd never close this quote. What will happen in this case? Well, the browser will try to load in this image and it will try to find a closing quote, and it will not find it on the page anywhere but on the bottom. So everything in between here that you can see becomes our get parameter here and is part of the get request, and the attacker can thus see that. That is kind of what a dangling markup injection is. However, as you can see here, there is no nonce in here. And that's because this nonce is only added on the page. That's because the CSP is only added on the page for when you view a note. So we need to first view a note. So what are we going to do? Well, we're going to create a new account, obviously, to have this dangling markup injection. We then need to create an account, create a note on that account. When we have that note, we then need to access it, but we don't have the UID, so we cannot access it. Thus, we need to first use this leak to leak the begin page, which shows all the notes. Then we can get the UID, and then we can do another leak to leak the actual post, which leaks the nonce. And here you can see some screenshots of that. So first of all, here we leak the begin page, and this shows us the UID, and then we leak again and we get the nonce. And that is how you can get the nonce in this case. So really cool way to do it. But now I think we have everything in place to start crafting an exploit. So let's get into that. Okay, so let's chain everything together here and make our exploit. And this exploit is really long and really difficult, so I am not going to show you all the code and all that, although you can obviously check it out for yourself. There is a write-up from the author that contains his whole exploit. And this is all crazy. So let's just start off with showing how the exploit works. So we visit this link, which is on an alt challenge, and things start to happen. And just like that, we have our XSS. Wow. Okay, I practiced for this, but let's try to recap what all of that does, what is happening here in less than 1 minute. So, okay, first things first, we need to open the first node of the victim. But to do that, we need to perform cookie tossing with the spoofed IP to enable the theme page for the victim. Then we create an iframe1, with a source doc, which opens another window with window.open. Then iframe1 changes its own location using location.replace to the begin page of the challenge. And then the child window changes its location after 1 second to the themes page with a callback to click the first node. And that's how we get the first node. Okay, so now we have this iframe with the first node, but now we need to leak the nonce. And for that, we need to create a new account with a username of a closing title tag, and then with our dangling markup injection payload. For that, we need to set up a server. I used ngrok, and this listens for requests with leak, with a leak, and then it grabs out the node ID and nonce. But to leak the nonce, we need to create a dummy node. And to create a dummy node, we first need to leak the secret. And we do that using web workers and blob URLs to bypass restrictions. But after we get the secret, now we can perform the CSRF to create a dummy post. Okay, after we have that, we can create another iframe with a dangling markup injection, which leaks the node ID. Once we have the node ID, we can create another iframe, the iframe number 3, which is going to do a dangling markup injection, but this time on the node that we created, and this will help us leak the nonce. So now we have everything we need. We have our nonce, we have the secret, we have everything. So let's create another account for actually executing the XSS, and this time it's again going to have the username that closes the title tag, and then we need to have our HTML attribute there with our type set to admin. That was to bypass that document.querySelectorAll thing. So now, in order to create a post with this XSS, we once again need a secret. So we need to use the same method that we used to leak the secret earlier, but we need to do it again. And now we can finally create a post with an XSS. That payload looks like this. So it starts with this href, and this href contains our prototype pollution. And now we have a bunch of stuff still going on there that I'm not going to go into. But after creating the node, we now need to use that SOM attack to go to that node. So we create a new iframe that is going to open another window, which is going to navigate to the XSS node. And then we have another window that opens, and this one is going to then click the A tag in our XSS payload, which contains the prototype pollution. And after that, that last iframe will be redirected to the href, which pollutes the prototype and enables a second parsing of our markdown, and that then triggers the XSS and we get our pop-up. Whew, jeez, what a story. This challenge has absolutely wrecked my mind. This day of recording this video has just been a full day of trying to figure out how it works and recording this video just for you guys, so you guys have something to watch and learn new things. And I really hope that you learned something new. I for sure did whilst recording this video. I can definitely tell you that I learned a lot of things here. But maybe we could let each other know what we learned in the comments down below. I'd love to hear from you how you would like this challenge, and if you're going to be there next month to solve the next one. So if you like this video, like it, and if you want to see more, be sure to subscribe, and I will see you next month for sure. See ya.